Let us start with our next chapter, measures of disease frequency. First question, which of the following must be considered while measuring the occurrence of a disease? Options are A, the number of people affected by the disease, B, population size from which the cases of disease arises, C, the length of the time the population is followed, or D, all of the above. So the answer for this question is D, all of the above. Okay, so the number of people affected by the disease, population size from which the cases of the disease arises, and the length of the time the population is followed, all must be considered while measuring the occurrence of a disease. Next question, dash is most useful for evaluating the impact of prevention program. What are the options? A, point prevalence, B, periodic prevalence, C, case fatality, or D, incidence. So what is most useful for evaluating the impact of prevention programs? Okay, so impact of prevention programs. So whenever you have this question, you have to put the answer as incidence. Now see, incidence is the answer. What are the uses of incidence? The data which comes out of incidence data, it describes the trends in diseases. Okay, sometimes they will ask an option as this, describes the trends in diseases, or otherwise evaluating the impact of primary prevention programs. Okay, so these are the two most important uses of incidence data. Next question, which one of the following statements is true? The options are A, high cure rate can increase the prevalence of a disease, B, low case fatality can reduce the prevalence of a disease, or C, both A and B are true, or D, high cure rate and high case fatality can reduce the prevalence of a disease. Okay, so what is the answer for this question? The answer for this question is D, high cure rate and high case fatality can reduce the prevalence of a disease. Please see this. Now see over here. Okay, this was the answer. You have to remember this chart. You have to remember the causes of increase and decrease in the prevalence. Invariably, one question or two questions may be asked from this chart itself. So what are the causes of increase and decrease of prevalence? Let us first complete our question. In our question, what was the first option? High cure rate can increase the prevalence of a disease. Is this the statement? The high cure rate will actually decrease the prevalence. So therefore, this is not the answer. Next is low case fatality can reduce the prevalence of the disease. Where is the low case fatality here? Low case fatality will in fact increase the prevalence of the disease. So even this is also not a statement. Now the option number C, that both A and B are true, we have already taken that both are wrong. Then the last option, that is high cure rate and high case fatality can reduce the prevalence of a disease. So high cure rate and high case fatality will decrease the prevalence of the disease. So this chart you have to by heart and you have to mug up, and it should be there on your fingertips, because invariably one or two questions may come in the examination from this chart. Next question, measures of disease frequency are what? Option number A, incidence, B, prevalence, C, birth rate, or D, both A and B. The answer is definitely both A and B. This is a simple question. Both incidence and prevalence are required for measuring the disease frequency. Next question, a measure that reflects the severity of an acute infectious disease is what? Okay, acute infectious disease, please remember, that reflects the severity. The options they gave are A, case fatality ratio, B, you have the incidence rate, C, prevalence, or D, mortality rate. So what is the answer? The answer for this question is A, case fatality ratio. Case fatality ratio, it reflects the severity of an acute infectious disease. Please remember this point. Now see over here, this was the answer we took. Case fatality will place in relation the number of deaths from a disease to the number of cases. Number of deaths to the number of cases. Okay, and second point is it reflects the severity. We got the severity in our question. Okay, and it can be expressed as a proportion or a ratio. Ratio is one of the option, okay, of an acute infectious diseases. So this is the answer for this question. Let us see the next question. Incidence data can be used to measure the occurrence of a disease with gradual onset. Is this a true statement or a false statement? The answer is that it is a false statement. Why? Now let us see over here. We took as a false statement because it is not the incidence data, it is the prevalence data. It is the prevalence data which can be used to measure the occurrence of a disease with gradual onset. Okay. Now you see the uses of prevalence data, it for the assessing the healthcare needs. Second is for planning healthcare services. Third one is to measure the occurrence of conditions with gradual onset. And fourth is the study chronic diseases. Okay, so this was the step which was asked, or this was the statement which was asked in our question. Okay. Now see this question. This measure reflects the impact of a disease on population in terms of death. So they are asking regarding impact of disease on a population in terms of death. The options are A, incidence density, B, case fatality, C is disease specific mortality, and D is attack rate. So what is the answer for this question? So whenever this question is asked that this measure reflects the impact of a disease on a population, when a population is mentioned, then you take the answer as disease specific mortality. For population, it is mortality. For an individual case, it is case fatality. Now see the discussion now further. We have taken disease specific mortality. Let us see. The prevalence is a static measure taken at a point in a time. Incidence is a dynamic measure taken over a certain time. Okay, at a point in a time, and this is over a certain time. So what is mortality? Mortality is calculated using population as denominator. For a mortality, you take population into consideration. But whereas case fatality, this is mortality, but whereas case fatality, for case fatality, you use only cases as denominators to reflect the severity. So for case fatality, only single case or cases. But for mortality, disease specific mortality, you take population. You please remember this difference. This has to be in your minds very clearly, because if in the question if this would have asked that this measure reflects the impact of a disease on a case, then it would have been a case fatality rate, but or case fatality ratio, to be more specific. But here they have mentioned population. Because they have mentioned population, we have taken disease specific mortality as the answer for this question. Next question. While measuring the frequency of a chronic disease in a community in terms of incidence per 1000 persons per year and point prevalence per 1000 persons, what is the expected pattern of incidence and prevalence? The options they gave are A, low prevalence and high incidence, B, high prevalence and low incidence, C is both prevalence and incidence will be the similar, or D, none of the above statements are true. So what is the question they have asked? While measuring the frequency of a chronic disease, please take this word, chronic diseases. So the answer for this question is that high prevalence and low incidence. Now see over here the patterns of incidence and prevalence. High prevalence and low incidence, example is the diabetes mellitus. Diabetes will always be a chronic disease, whereas low prevalence and high incidence will be, for example, a common cold. This is an acute disease. Okay. So therefore, for a chronic disease, example is diabetes mellitus, the pattern will be high prevalence and low incidence. Please remember this point. Now let us see the next question. In a study among 3,400 children aged between 5 to 10 years, 16 children were diagnosed with the autistic disorder. Then calculate the prevalence of autism per 1000 children they have asked. The options they gave are A 4.01, B 5.53, C 3.35 and 4.71. So let us see how do we calculate. See, the formula is they are asking to calculate the prevalence. So prevalence is equal to, that is P is equal to C by N. Okay, prevalence is equal to C by N. So what is C? C is equal to the number of observed cases. How much it will be? It is equal to 16. Okay, then what is the what is N? What is N? N is equal to total number of cases at that time. So total number of cases is how much? 3,400. So P is equal to 16 by 3,400. 16 by 3400. Then if you calculate this, it will come around 0.0047. okay, so 0.0047 if to multiply with 100, okay, because sorry, per thousand, because we want 1000 per 1000 children years, so it will be 4.70, which is approximately 4.71. So this should be the answer for this question. This is how you have to solve. Please remember the formula: P is equal to C by N. P is equal to C by N. Prevalence is equal to C by N. Okay. Then next question: statistics used to estimate the risk of acquiring a disease is what? The options are A, prevalence, B, incidence, C, mortality rate, or D, all of the above. What have they asked? What is the statistics used to estimate the risk of acquiring a disease? Acquiring a disease is incidence. Please remember this point. Acquiring a disease is incidence. Next question: what is the appropriate measure when a researcher wishes to know the burden of a particular disease in terms of number of deaths it causes in a specified geographical region and population? Okay, you please remember once again, we will see the question: what is the appropriate measure when a researcher wishes to know the burden of a particular disease in terms of number of deaths it is caused in a specified geographical region and population? Okay, so they have not mentioned time period over here, because let us see the options first. The options are incidence density, B, case fatality, C is attack rate, and D is disease specific mortality. Now in the incidence density, what is required? You require time, because the denominator will be time person observation. Okay, then attack rate is what? Attack rate is also time period of observation. Even in attack rate you will have time period is important. Okay, because they have not mentioned any time in the question, so these two options are not involved. Okay, now it is between case fatality and disease specific mortality. Now how do you differentiate? Okay, so the answer for this question will be a disease specific mortality. Why disease specific mortality? Now let us see over here. We have mentioned that the answer is disease specific mortality. We will see the mortality. Mortality is calculated using population, okay, denominators to reflect the burden, whereas case fatality is calculated using cases, okay, individual cases as denominators. Whereas when you take the whole population into consideration, then mortality term will come into picture. If you take cases into consideration, then case fatality particularly will come into picture. Once again, they have asked, in the question itself they have mentioned that in a specified geographical region and population. For that is the reason we have taken case for disease specific mortality. If they could have written a single case, then it could have been, the answer could have been a case fatality. Okay, so please remember the difference between mortality and case fatality. Next question: if health policy makers want to evaluate the impact of a prevention program, which is appropriate measure to be considered? The options they gave are A, period prevalence, B, incidence, C, point prevalence, or D, case fatality. If the health policy makers want to evaluate the impact of a prevention program, this we have already seen. The answer for this is B, incidence. Incidence is the answer for this. We have already seen the explanation. Next question: select the correct statement among the following. The options are A, prevalence of a disease will increase when it has a high cure rate. B, prevalence of a disease will decrease when it has a low case fatality ratio. C, prevalence of a disease will increase when it has a low cure rate. Or D, prevalence of a disease will increase when it is acute in nature. Okay, so what is the answer for this question? What is the correct statement? They have asked. The correct statement is option number C, that is prevalence of a disease will increase when it has a low cure rate. For this, please go to question number 3. Okay, please go to question number 3, because we have discussed regarding the causes of increases and decreases, the causes of increase and decrease in the prevalence. Okay, so please go to question number 3 and review the answer once again. But as far as this question is concerned, the answer for this question is option number C, that is prevalence of a disease will increase when it has a low cure rate. Then coming to the next question, point prevalence is given by the formula. What? It is very simple question. Point prevalence is equal to C by N. Just now we have discussed few questions back. That is point prevalence is equal to C by N. C is the number of cases at that time and N is the total number of population at that time. Next question. Cumulative incidence is otherwise known as what? The options they gave are A, attack rate, B, case fatality rate, C, mortality rate, or D, morbidity rate. It is very simple question. Cumulative incidence is otherwise also called as attack rate. It is also called as attack rate. Next question. The healthcare professionals working in an intensive care unit were asked whether there has been an increase in the number of new pneumonia cases. So which of the following factors is inappropriate in the calculation of cumulative incidence? So the options are A, number of new cases of pneumonia during a specified period of time, B, total number of people at risk of developing the disease in that population during the same period of time, or C, pre-existing cases of pneumonia, or D, both A and B. See, in the question they have asked which is an inappropriate, which is not appropriate in the calculation of cumulative incidence. So the answer for this question is C. Pre-existing cases of pneumonia are not appropriate for calculating the cumulative incidence. Cumulative incidence in the sense new cases. So option number A, that is total number of new cases during a specified period of time, will be taken into consideration, and the total number of people at risk of developing the disease in that population at that period of time will be taken into consideration. The pre-existing cases of pneumonia are not taken into consideration. Now let us see the next question. When measuring the frequency of an acute infectious disease in a community in terms of incidence per 1000 persons per year and point prevalence per 1000 persons, how will be the pattern of incidence and prevalence will be? The options are A, high incidence, B, low prevalence, the options are A, high prevalence, B, low incidence, C, both prevalence and incidence will be similar, or D, low prevalence and high incidence. So what is the answer for this question? The answer is, it is D, low prevalence and high incidence. Why? See, because when you are measuring the frequency for an acute infectious disease, whenever you see an acute infectious disease, then you have to say that it is a low prevalence and high incidence. For further discussion, please refer to question number 8. Okay, question number 8. Please go to question number 8, because we have discussed in detail regarding the high prevalence, patterns of prevalence and incidence in diseases in question number 8. Then next question, among 20,000 25,000 population in a city, 105 residents were identified with hepatitis B infection. Then calculate the prevalence of hepatitis B per 1000 population. They have asked for prevalence. The options they have given as 5.2, 4.2, 3.2 and 2.2. So let us calculate. P is equal to C by N. Okay, this is the formula for prevalence. Now what is C? C is 105. Total population is 2500. Now when you calculate, this will come to 0.0042, and if you multiply with because they have asked per 1000 population, you multiply with 1000, the answer will be around 4.2. So this is the answer for this question. Next question, which of the following condition tends to increase the prevalence of a particular disease? Tends to increase the prevalence. The options are A, high cure rate, B, low case fatality ratio, C, short duration, or D, immigration of patients. The answer for this question is B, low case fatality ratio. B, low case fatality ratio tends to increase the prevalence of a particular disease. Please go to question number 3 of this discussion and of this chapter and review the whole question once again. There we have explained in detail regarding the causes of increases or decreases in the prevalence. Next, which of the following is true about incidence density? The options are A, numerator has number of new cases, B, it is also called as cumulative incidence, or C, denominator is the number of persons at risk, or D. Numerator has person years at risk. So for incidence density, you take numerator has a number of new cases. Okay, now see over here. We have taken numerator has the number of new cases in incidence density. Incidence density is also called as incidence rate. Okay, cumulative incidence is a different entity. So numerator has number of new cases. Okay, so this should be the answer for this question. Next question. In a rural block with 1 lakh population, 250 residents were identified with cardiovascular disease. Then calculate the prevalence of cardiovascular disease per 1000 population. By this time you should know how to calculate. P is equal to C by N. They gave few options. What is P then? P is equal to what is C? 250 by 1 lakh. Lakhs. Okay. Into 1000 because they have asked per 1000 population. So remove this, remove this, remove this, remove this. 2.5. Answer is 2.5. So this is how you have to calculate. Next question. What is the appropriate epidemiological measure to determine the burden of a disease in terms of number of cases presenting in a specified geographical area at a specific point in time? At a specific point in time. Therefore, whenever they have taken time into consideration, okay, you immediately remove case fatality ratio. Okay, then the answer for this question will be point prevalence. Answer for this will be point prevalence. Point prevalence is the appropriate epidemiological measure to determine the burden of a disease in terms of number of cases presenting in a specified geographical area at a specific point in time. So it is called as point prevalence. Okay, please remember this point. Next question. In a study, 300 children were followed up for a period of 1 year to determine the burden of acute respiratory infections. So calculate the incidence density if the total number of acute respiratory infectious episodes recorded was 1500. The options they gave are 5 episodes per child, 0.2 episodes per child year, 3 episodes per child year, and 0.5 episodes per child year. Now how will you calculate? See, now we will write down incidence density is equal to the number of new cases divided by total person time of observation. Okay, total person time of observation. So it will be 1500 divided by 300. Okay, so it will be 5 episodes. Okay, 1500 divided by 300 is equal to 5 episodes. The answer for this question is this one, 5 episodes per child year. You please remember this formula. Number of new cases by total person time of observation. Now, let us see the next question. A total number of 100 people with hypertension were followed for 3 years to observe for development of MY in a cohort study. So at the end of first year, 10 people developed myocardial infarction. Then at the end of second year, 10 people left the study. And then at the end of third year, another 10 people developed myocardial infarction. So calculate the total person years of observation in this study. The options they gave are 250, 260, 270 and 280. Now how will you solve this question? Please listen carefully. First of all, the solution is that you first see the number of people with hypertension. How many people are there with hypertension? 100 people are there with hypertension. Okay, so now duration of observation is for 3 years. 3 years duration. They gave 3 years to observe. Now what is happening over here? You have to remember the point that total person years of observation will be equal to the total person years of observation will be equal to it will be the sum of time of each person remained under observation and should be free from disease. This point you have to remember. They should be free from disease plus at the same time each person should be at that time. Each person at that time should be taken. Okay. So how will you calculate? We have taken as 100 hypertension patients. The study duration is for 3 years. Okay. So the number of participants observed during first year is 100. Next, what is happening? Number of participants during second year, what is happening during second year? Only 90, because 10 people have developed MI at the end of first year. Okay, so because 10 people have developed MI, our clause was they should be free from disease. So 90 second year. Okay, then finally third year, what will be? Third year will be 80. Why 80? Because 10 people have left the study. So each person present at that time is another criteria. So by the end of third year, only 80 are present. Okay, so when you total 100 plus 90, because our duration is only 3 years, 100 plus 90 plus 80 is equal to 270. So the answer for this question is 270. Most important is that the number of people, this last option, see over here, another 10 people developed MI. This number will not be taken into consideration, because number of people who develop disease at the end of last year, they won't be considered for person years. Please remember this point. Okay, now coming to the next question. During a 1-year follow-up, a psychiatrist determined the burden of suicidal ideation among 100 patients with drug addiction. So 7 patients had a previous history of suicidal ideation and 20 patients developed it for the first time. So what is the incidence of suicidal ideation in the study population? Incidence they have asked. They have given few options: 7%, 20%, 21.5 and 27%. Now let us see how do we calculate. This incidence is equal to number of new cases in a specified time. Please remember, in a specified time divided by you take total population at risk at the beginning. You have to take total population at risk at the beginning. So how many are the new cases? New cases are 20. Okay, then what is the total population at risk at the beginning? Is it 100? No, it is not 100, because 7 patients had a previous history of suicidal ideation. So 100 minus 7, it will be 93 only. Please remember this point. Okay, then upon substitution, how will you get the answer? It will be I is equal to 20 by 93. Okay, into 100 you have to do, which will be almost 21.5. So this is the answer for this question. Okay, so this is how you have to calculate this and answer this question. Next question. In a food poisoning outbreak, 75 people were affected. Among them, 550 people were hospitalized and 2 people died. So calculate the case fatality ratio. They have given few options: 1.2%, 2.7%, 4% and 8%. How will you calculate? Case fatality ratio is equal to number of deaths we have seen before by number of cases. Case fatality ratio. Okay, so number of deaths is how much? 2 by number of cases 75 into you do 100 ratio. How much you will get? 2.66, which is almost equivalent to approximately 2.7%. This is the answer for this question. This is how you have to calculate. Next, which of the following is not required for calculating the prevalence of a disease? Not required. The options they gave are: A, pre-existing cases of the disease; B, new cases of the disease; C, total number of people at risk; or D, total person time of observation. So which is not required for calculating the prevalence of a disease? Straight away the answer is D. Total person time of observation is not required for calculating the prevalence. It is required for incidence. Now see the explanation for this question. See the explanation over here. We have the formula for point prevalence and then we have the formula for incidence density. Please by heart the formulas. P is equal to C by N, and here incidence density is equal to number of new cases by total person time of observation. Now in our question, they have asked that which of the following is not required for calculating the prevalence of the disease. Prevalence of the disease, prevalence will involve both the old cases and plus also the new cases. So if it is old plus new, then it is called as period prevalence. If it is only old cases, then it is point prevalence. We know that. So what are the options? Pre-existing cases of the disease, which is required for the calculating prevalence of the disease. New cases of the disease are also required. So previous cases and new cases both in period prevalence. Only old cases in point prevalence. Okay. And total number of people at risk. That is the denominator value. So what is not required for the calculating? The total person time of observation is not required because this denominator is used in the calculation of incidence density. So I request all the students to be perfect with both these formulas. Next question. Which of the following condition tends to reduce the prevalence of a particular disease? Which of the following condition tends to reduce the prevalence of a particular disease? Options are A. High cure rate, B. Low case fatality ratio, C. Improved case detection rate, D. Immigration of diseased people. This is a repeated question. The answer for this question is A. High cure rate will reduce the prevalence of a particular disease. You please go to question number 3. We have discussed in detail regarding the causes of increase or the causes of decrease in the prevalence. Next. In which of the following conditions prevalence is an appropriate measure of disease frequency? The options are A. Common cold episodes in elderly, B. Number of exacerbations in asthma patients, C. Proportion of foot ulcers in diabetes mellitus, or D. Number of diarrhea episodes in children. So in which of the following conditions prevalence you have to take mostly for chronic conditions. High prevalence and low incidence we have discussed previously. Go to question number 8 and see the discussion over there. See the options given over here. Common cold is acute. Number of exacerbation in asthma is acute. Foot ulcers in diabetes mellitus chronic. Number of diarrhea episodes chronic. Diarrhea episodes is acute again. So the answer for this question is C. Okay, so this is how you have to remember and answer the question. Next one. Which of the following is incorrect about the case fatality? The options they gave are A. It reflects the severity of the disease. B. High case fatality indicates poor prognosis. C. It relates to the number of deaths to the number of cases of a disease. Or D. It is a true rate. So which of the following is incorrect about the case fatality? Let us see the options again. It reflects the severity of the disease. Yes, we have seen. High case fatality indicates poor prognosis. Yes. It relates the number of deaths to the number of cases. Yes, even this is the correct statement. What is incorrect statement? That it is a true rate. It is not a true rate. We always call it as case fatality ratio. Case fatality rate is the term case fatality rate is not used. We always use case fatality ratio. See over here. It can be this case fatality place in relation to the number of deaths from a disease to a number of cases. This option is there. Okay. High case fatality indicates poor prognosis. Yes, definitely we know. It reflects the severity of the disease. Even this is over here. So these two options are given. Then see the third important statement. Case fatality can be expressed as a proportion or as a ratio, but not as a rate. Not as a rate. Okay. Although often referred to as case fatality rate, but never. So this statement is actually a wrong statement. So it is case fatality is never expressed as a rate, always as a proportion or as a ratio. Next question. Now see this question. A population of 150 persons is present and you follow up for 1 year. 25 persons had a disease of interest at the beginning, and another 15 new cases developed during the year. Now calculate the point prevalence at the start of the period and also the period prevalence for the year. They have given different options like 17% and 27%, 1.7% and 2.7%, 170% and 270%, and option number D 0.17% and 0.27%. So how do you calculate? Let us see first the point prevalence. Point prevalence is given by the formula P is equal to C by N, where C is the number of old cases. So what are the number of old cases? Number of old cases are 25. My total number of cases is 150 into percentage 100. So if you calculate this comes approximately 16.66%, 666%, which is, so that's why we have taken rounded as 17%. If you take periodic prevalence or period prevalence, it is C plus I by N. C is equal to 25 plus 15 by 150. So it will come to around 40 by 150 into 100. Why 100? Because you have to give in percentage. This comes to around 26.666 value, that is 26.66%, which is equivalent to 27%. So therefore, option number A is the answer for our question. So this is how you have to calculate. Please remember the formula of point prevalence P is equal to C by N. For periodic prevalences, PP is equal to C plus I by N. Next question, state whether true or false. Risk is a probability that an individual will experience a health status change over a specified follow-up period. Is this a true statement or a false statement? Definitely this is a true statement. This is a true statement. Now see the explanation over here. What is risk? The probability that an individual will experience a health status change over a specified follow-up period is called as a risk. So this is a definition of risk. In our question, they have asked the similar sentence that risk is probability that an individual will experience a health status change over a specified follow-up period. So we have taken the answer as a true answer, true statement. So this is the definition of risk. So let us continue, or let us finish this discussion on this risk. The risk assumes that the individual does not have the disease at the beginning and die from other causes during the follow-up. So this is important. These are the criteria for the risk of a disease. And most importantly, that the risk should correspond to the cumulated incidence. Okay. So all the students, please remember this chart on risk. Next question. Increase in the prevalence could be of long duration, short duration, mid duration, or no duration. What is the answer? We have already said prevalence for chronic cases. So it is a long duration. Increase in the prevalence could be for long duration. Now, let us see this question. 100 people with hypertension are followed up for 5 years to observe for the development of myocardial infarction. At the end of second year, 5 people develop MI, and at the end of third year, another 2 people develop MI, and at the end of 5 years, 3 people develop MI. So calculate the incidence rate of MI. So they have given many options. Let us see how do we calculate this question. So number of participants observed during first year is how much? 100. Number of participants observed during second year is again 100 only. Because at the end of second year, 5 people developed MI. So then at the end of second year, 5 people developed. So third year, how many people will be there? 100 minus 5 is equal to 95. Please remember this point. Then at the end of third year, again, 2 people have developed MI. So in the fourth year, how many people will be there? 95 minus 2 is equal to 93. Okay. Then number of participants observed during the fifth year is again 93 only. Because at the end of 5 years, 3 people have developed. So fourth year and fifth year, 93 people will be there. Now total everything. If you total 100 plus 100 plus 95 plus 95 plus 93, sorry, 100 plus 100 plus 95 plus 93 plus 93, it will come to 481. Okay, it will come to 481. So the answer for this question is 10th by 481 cases per year. So this is how you have to calculate. Next question. Dash measures the rapidity with which new cases are occurring in a population. The options they gave are A. Cumulative incidence, B. Incidence, C is the occurrence, or D. Incidence density. The answer is C. Occurrence. Occurrence measures the rapidity with which new cases are occurring in a population. Now let us see the next question. Cumulated incidence is also known as attack rate. Is it a true statement or a false statement? Yes, it is a true statement. Please see this chart or the discussion on cumulated incidence formula. Cumulated incidence is equal to the number of new cases by population at risk at the beginning into 10 to the power 10. It is also called as attack rate. It is also called as attack rate, and it assumes that the entire population at risk at the beginning was followed up for the time period of observation. So this is called as cumulated incidence. In our question, they have mentioned the cumulated incidence is also known as attack rate. So we have taken this as a true statement, and it is also mentioned in this chart. So all the students, please become perfect with the formula and the definition of this cumulated incidence. Next question. Fatality can be expressed as what? Proportion and rate, rate and ratio, sum and multiplication, or otherwise proportion and ratio. So fatality can be expressed as proportion and ratio we have seen. Now see this question. The following is the relation between prevalence P, incidence I, and duration D of the disease. What are the options? Option number A. Prevalence is equal to incidence into the duration of the disease, that is P is equal to I into D. Or option number B, incidence is equal to prevalence into the duration of the disease. Or option C, the duration of the disease is equal to incidence into prevalence. Or option number D, the prevalence is equal to duration of the disease by incidence. So what is the correct relationship and the answer between prevalence, incidence, and duration of the disease? The answer for this question is option number A, that is prevalence is equal to incidence into duration of the disease. Now see this discussion, the relation between prevalence and incidence. All the students, please go through this information thoroughly. You have to know what is prevalence, what is incidence, what is duration, and the relationship between all the three terminologies. Prevalence is equal to incidence into disease, into the duration of the disease. So it is a change in the prevalence from one time period to another may be the result of changes in incidence rates and changes in the duration of the disease, or both. Okay, so a change in the prevalence from one time period may be a result of either changes in the incidence rates or changes in the duration of the disease, or both. So that is, if you want a P to be changed, either I should be changed or D should be changed, or both I and D should be changed. So you please remember the small discussion on the relationship between prevalence, incidence, and the duration of the disease. Next question. Fatality reflects how much? Severity, mortality, morbidity, fraternity. Fatality reflects severity. Next is prevalence and incidence. Prevalence and it is incidence. Okay, typing error. Depends upon the duration of the disease. Is it a true statement or a false statement? Prevalence and incidence depends upon the duration of the disease. Is it a true statement or a false statement? Is it a true statement? Next question. All of the following are measures of morbidity except what? The options are A. Incidence, B. Probability of experiencing a disease condition, C. Population at risk of a disease, or D. Period prevalence. So all of the following are measures of morbidity except what? So the answer for this question is C, that is the population at risk of a disease. Next question. The ratio of the number of cases to the total time of population at the risk of disease refers to what? The options are A. Cumulative incidence, B. Incidence density, C is risk, or D is incidence proportion. Incidence density is the answer. Incidence density is equal to, we have calculated also, number of new cases divided by total time, the population at risk. Okay. Then next question. A cross-sectional survey was undertaken to estimate the prevalence of refractive errors among adults in a village with a population of 10,000. Okay. Then during the survey, about 400 reported spectacle use for the refractive error, and another 800 individuals were identified with refractive error during the survey. So what is the prevalence of the refractive error? The options they gave are 8%, 8.3%, 12% and 12.3%. Prevalence, what is our formula? Prevalence is equal to C by N. Okay. So prevalence is equal to, what is C? C is total cases, total number of observed cases. How much are there? They have given 400 plus another 800. Okay. So which is equal to 1200. Okay. Then so this is C. This is C. Now what is N? N is the population size. It is 10,000. So P is equal to 1200 by 10,000, which will be equal to 0.12. If you multiply, if you multiply with 100, is equal to 12%. So this is the answer for this question. Okay. The only difference is that they have given at two different points, two different number of patients. Okay, because 400 reported spectacle use for refractive error and another 800 individuals were identified with refractive errors. So totally 400 plus 800 is equal to 1200. This is a change in this question. Okay. Now, next question. Which of the following is false about the disease prevalence? The options are A. It is the ratio of existing cases to the total population at risk during a specified time point. Or B. The total mid-year population is used as an approximation for population at risk wherever at-risk population is not available. And C. The multiplier is chosen depending upon how rare or common the disease being studied is. Or D. Prevalence is the appropriate for measuring the burden of disease with high fatality. So the answer for this question is directly D. Prevalence is appropriate for measuring the burden of disease with high fatality. Is false about the disease prevalence. Next question. Which of the following can decrease the prevalence of a disease? How will you decrease? The options are A. Increase in the incidence of the disease. B. Improved detection of the diseased individuals. C. High case fatality. Or D. Immigration of patients with the disease into a study area. So how will you decrease the prevalence? By high case fatality. High case fatality can decrease the prevalence of a disease. The causes of increase and decrease in prevalence we have discussed previously. Please go to the discussion in the initial questions of this chapter. You will have a discussion over there and review again. Next, which of the following statement is false about incidence of the disease? The options are A. It measures the rapidity with which new cases are occurring in a population. Or B. It is the number of all existing cases, that is old and new, during a given period in a specified population. Or C. It can be expressed as a cumulative incidence or incidence density. Or D. Cumulative incidence is also referred as attack rate. So which of the following statement is false about incidence of the disease? We will see the options again. It measures the rapidity with which new cases are occurring in a population. Yes, this is a true statement. It is the number of all the existing cases, new and old, during a given period in a specified population. No. Old, no. This is not the statement. So therefore, this is a false statement regarding incidence of the disease. Then it can be expressed as cumulative incidence or incidence density. Yes, this is also a true statement. Cumulative incidence is also called as attack rate. Yes, even this is a correct statement. So we have got the answer over here, that option number B, that is, it is the number of all existing cases during a given period of time in a specified population, including the old cases, is a false statement about the incidence of a disease. Next question. A cohort of women who smoked cigarettes was followed up to study the incidence of cleft lip among the children born to these women. So out of this, 9,500 children born to these women, 228 had cleft lip. What is the risk of cleft lip among women who smoke the cigarettes? So, once again, they have asked, what is the risk of cleft lip? So, incidence is equal to number of new cases in specified time. In specified time, number of new cases divided by total population at risk. So, how much was the number of new cases? 228. What is the total population at risk? Children 9,500. If you calculate, you will get an answer of 0.24. 0.24 you multiply with 100, which will be 2.4 per 100 person years. Okay. The answer for this is this one, 2.4 per 100 person years. The next question. Now let us see this question. In a school, there are 150 children and screening is being done for refractive errors, out of which 15 students require glasses. So calculate the prevalence of refractive errors in that school. So what is the formula? And they have given options. Options are 10%, 100%, 1000% and 1%. So what is the formula? Formula for prevalence is equal to C by N. What is number C over here? By this stage, all the students should be able to identify what is C, what is N. So C over here is number 15. And what is N over here is 150. And you have to give the answer in prevalence. So therefore multiply with 100. So this comes to around 10%. This is equal to 10%. So the answer for this question is option number A. So this is how you have to calculate the question. Next question. About 100 prison inmates were followed up for 1 year to study the occurrence of TB among them. Of the total, 10 had TB at the beginning and another 25 persons developed TB during the 1 year of follow-up. What is the period prevalence for that year? Period prevalence, not point prevalence. Okay. Now let us see how it is calculated. What is the formula for period prevalence? Period prevalence is written as PP. PP is equal to C plus I by N. Whereas our point prevalence was C by N. Okay, this was point prevalence. Period prevalence is C plus I by N. So you substitute all the things. What is the incidence? I is 25. What is C? Prevalent cases 10. What is total population size? 1000. Okay. So you calculate substituting the values 25 plus 10 plus 25. It is 10 plus C is 10. 10 plus 25 by 1000, which is equal to 0.035. If you multiply again with 100 for percentage, you will get 3.5%. So answer for this question is 3.5%. So this is how you have to calculate. Now the last question, state whether true or false. Change in the prevalence from one time period to another may be the result of changes in the incidence rates and changes in the duration of the disease, or both. Is this a true statement or a false statement? Definitely it is a true statement. Change in the prevalence from one time period to the another may be the result of changes in the incidence rates and changes in the duration of the disease, and both. Okay. So with this we come to the completion of our fourth chapter, that is measures of the disease frequency. Thank you.